Chapter 3, Rope and Related Equipment. The JPR objectives for Chapter 3 are first going to be to determine which rope to use for a task, identify and describe fibers used to make rope, identify and describe different types of rope construction, describe the considerations for choosing a rope, describe the process of coloring rope and its advantages and disadvantages, describe accessory cord and discuss its use in the high-angle environment, and describe webbing and discuss its use in the high-angle environment. Rope Rescue Level 1 Objectives. Going to describe how to determine a system's safety ratio, describe how the breaking strength of rope is measured, explain how to calculate the fall factor and its role in rope rescue. Determining the right rope for the task. Rope is a universal link in high-angle activities and rope rescue. Many different kinds of rope are used for high-angle activities. Each kind has a specific design and fiber that determine how it reacts to natural and human forces. The incorrect use of a rope can have catastrophic results. NFPA 1983 delineates different types of rope. There's two major rope classifications for technical rope operations. You have life safety rope and moderate elongation laid life-saving rope. Others include water rescue throw lines and escape ropes. Ropes for technical climbing and mountaineering. Ropes for climbers and mountaineers are designed to catch the user if the person falls when climbing. A good climbing rope also helps reduce the force that is transmitted to anchors and protection. This kind of rope is called dynamic or a high stretch rope. Dynamic rope. Its ability to stretch is built into it during the manufacturing process. It's achieved through various designs that elongate under a load. Dynamic ropes for climbing and mountaineering are soft and pliable. As you can see from this photo of dynamic Kernmantle rope, the core fibers have a twist that when loaded will elongate up to 60%. This elongation helps to absorb forces on the climber, the hardware, and the anchors in the event of a fall. Ropes for rappelling and ascending. The stretch of dynamic rope is counterproductive when trying to ascend or rappel. A static or low stretch rope would be more appropriate. The lack of stretch in these ropes allow for greater control of the rescuer. If you were trying to ascend a dynamic rope, you would have to take up all the stretch in the rope before you could ascend. Conversely, if you were trying to rappel, it would be difficult at best to try and accurately stop at the correct point with dynamic rope. Static or low stretch rope. If you look at this picture of static Kernmantle in comparison to the dynamic picture, you'll notice the core fiber bundles have drastically less twist, which equates to much less elongation or stretch. Ropes for rescue use. In the area of rescue use, control of the rope is essential. This is what allows rescue crews to accurately lower or rappel to a location and also effectively and efficiently raise or ascend. Rope materials, natural fibers and synthetic fibers. Natural fiber ropes are condemned for life safety use due to low resistance to abrasion, limited ability for shock absorption. They degrade in strength despite the best care. They can rot without any outward signs. They have lower breaking strengths than the same diameter synthetic rope. And they don't have strands that are continuous along the rope's entire length. Natural fibers are only a few feet long. Natural fibers continued. Natural fibers used include sisal, hemp, and manila. Synthetic fiber ropes. Synthetic fiber ropes have several important advantages over natural fiber ropes. As they do not rot, they do not age nearly as quickly. They can be made into more advanced rope designs than natural fiber ropes. And each fiber has distinct characteristics that make it suitable for certain uses and unsuitable for others. Synthetic fibers include polyolefins, and that would include polypropylene and polyethylene. You have HMPE, or extended chain high-modulus polyethylene, aramids, Kevlar, which is an aramid fiber, polyester, and nylon. Polyolefins are often found in water activities. The advantages that they provide is they don't absorb water, so they float. Some of the disadvantages, they have a very low tensile strength, very low abrasion resistance, and low melting point. Extended chain high-modulus polyethylene, or HMPE, it's a polyethylene yarn. The best known brand in the United States is Spectra. It is very slippery and does not hold knots very well, and it has poor shock absorbing qualities. Aramid fibers forming material is a long chain synthetic polyamide. At least 85% of its amide linkages are attached directly to two aromatic rings. Kevlar. Kevlar is an aramid fiber. Kevlar possesses many characteristics that would make it undesirable for many rescue operations. The rope it has very low abrasion resistance, and continued small radius flexing, for example, repeated knotting and unknotting, can weaken the rope. Polyester. Polyester is a great choice when a rope with minimal stretch is desired. While it makes a quality lowering or rappelling rope, it would not be the best choice for a belay line where the risk of a shock load is possible. Polyester fibers do not absorb water, so there's no loss of strength or increase in weight if the rope gets wet. Polyester is an excellent choice for high lines, long rappels, and many mechanical advantage hull systems. Nylon. There's two main examples of nylon construction. You have nylon 6, which is also known as Perlon, and nylon 6/6. Perlon has better elongation and better shock absorbing qualities than nylon 6/6, and it's found in most types of climbing ropes. Nylon 6/6 has a slightly higher melting point and a slightly higher breaking point than nylon 6 or Perlon. It shows slightly better resistance to wear and less elongation under load, and it's found in most static or low stretch ropes. Advantages to nylon is it's 10% stronger than polyester ropes of the same diameter, and some disadvantages to nylon include it may lose 10 to 15% of its strength when it's wet. It does regain this strength when the rope dries, but it's also more expensive than polyester. Nylon ropes are widely used in the rescue arena. Ropes made of nylon yarn are commonly used in life support applications where there's a chance of shock loading the system, including climbing, vertical caving, rescue, and tactical operations. Different constructions present with different characteristics just as different fibers do. Laid construction. Laid construction resembles the designs of older types of natural rope fiber. It's also known as twisted or hawser lay. Small fiber bundles of material are twisted and then combined in larger bundles, usually in groups of 3, which are twisted around one another in the opposite direction. Laid rope adds a great amount of spin during a rappel, which can be undesirable. It tends to be very stretchy and is susceptible to damage from abrasion. Ropes of laid construction have been displaced in most high-angle work by other designs. Plaited construction usually consists of bundles of fibers that are plaited together. They tend to be soft and pliable. They are prone to picking or snagging and pulling out of the fiber bundles. Braided construction. You have solid single braid rope, which is constructed entirely of a single weave of 3 or more fiber bundles. It's sometimes called a clothesline braid, has limited use in high-angle operations. And then hollow braid rope, essentially a very thick sheath, sometimes has a filler such as a scrap yarn or filament plastic. These are typically found in inexpensive hardware store type rope, not in life safety line. Double braid construction. Essentially a rope constructed of a solid braid covered with a hollow braid. One braid acts as the rope core. The second braid is constructed around it to act as a sheath and help protect the inner braid. What other type of rope construction does double braid resemble? Kernmantle construction. Kern means core. The core supports the majority of the load. The mantle means sheath or cover. This supports a lesser portion of the load. Kernmantle construction produces a rope that is strong and resists damage, but is easy to handle. It's widely accepted as the standard for life safety operations. Dynamic Kernmantle. This is a rope with high stretch. It can stretch as much as 60% before breaking. The stretch acts as a shock absorber. The elasticity of these ropes makes them less suitable for rappelling and ascending. It is an excellent rope for belay operations due to its shock absorbing characteristics. This decreases the impact on the rescuer, the hardware, and the anchors in the event of an impact load. Static Kernmantle. It's a type of rope with very low stretch. We're talking less than 6% stretch at 10% of the minimum breaking strength. A rope core or fiber bundles that are nearly parallel to one another creates this very low stretch rope. Static Kernmantle is a great choice for high line, single rescue technique, and any other operation where stretch is not desired. These parallel fibers have minimal twists, so when they are loaded, this minimal twist, it resists straightening or stretching. Low stretch Kernmantle has a little more stretch than static Kernmantle ropes have. We're talking 6 to 10% strength at 10% of the minimum breaking strength. Most have a slightly more twist in each core strand. Static or low stretch Kernmantle have so little stretch they cause a more abrupt stop when catching a fall. This subjects the climber's body, the equipment in the system, and the anchors to greater impact loading than would a dynamic rope. These static and low stretch Kernmantle ropes also have a thicker, tighter sheath than do dynamic Kernmantle ropes. The thicker, tighter sheath of static and low stretch Kernmantle gives the rope a stiffer hand. Dynamic versus static or low stretch ropes. Dynamic ropes should be used if you're only doing recreational rock climbing or mountaineering. Dynamic rope is also appropriate if the rope is going to be used as a belay for falls that result in severe shock loading. Static or low stretch rope should be used if your activities are going to be restricted to rappelling and ascending. And static or low stretch rope is used by most rescue workers in their operations. Moderate elongation laid life-saving rope. A specialty line for supporting people during rescue at firefighting operations or training evolutions. It's laid construction, also known as twisted or hawser lay, as mentioned earlier. Remember the difference between moderate elongation laid life-saving rope and life safety rope is life safety rope, according to its NFPA definition, is also suitable for other rescue operations. Kind of a tricky play on words, but important to know the difference. Size and strength. The strength of rope, also known as tensile strength, depends on its cross-section of material or the amount of yarn used per foot of length. The larger the diameter of the rope, the more difficult it is to manipulate. This is also termed as the hand. A rope that is difficult to manipulate is said to have a strong hand. The stronger a rope is, the less it stretches. A lack of stretch means poor energy absorption when force is suddenly applied to the system. Size and strength. For their main rescue lines, most rescue teams select static or low stretch Kernmantle ropes in the diameter of 7/16 inch or 1/2 inch. Problems with large diameter ropes. Larger diameter ropes have a higher cost, greater weight, they're difficult to handle at times, and they can have incompatibility with certain equipment. Speaking of incompatibility with equipment, if you look at the images here, the red MPD is designed for use with a 13 millimeter rope. The gray MPD is designed for use with an 11 millimeter rope. What could be the consequences if the wrong size of rope is used? Too large a rope is going to have high friction and may not be able to get the back of the MPD closed. Too small of rope, the friction system may not be able to supply enough friction to stop the rope during deployment. Rope colors. Color can serve multiple purposes. If several ropes are used together, the different colors can help distinguish one line from another. You can buy a different colored rope for each year, making it easier to identify the age of the rope. Varying colors can be used for different sizes of rope. Why is it important to be able to distinguish between ropes? To help identify which rope may need slack or tension. The process for coloring ropes. There's two different processes for dyeing rope. The first one is solution dyeing. This occurs during the manufacture of the yarn. It typically weakens the rope greater than surface applied dyeing. Surface applied dyeing is when the color is added after the yarn has been manufactured. It does weaken the rope less due to the dye only being applied to the mantle of the rope. Manufactured supplied eye termination. It's a permanent loop in the end of a rope created by the rope manufacturer that makes for a quick rigging or hooking to connections, such as the davits on some helicopters. NFPA 1983 now has performance test standards for manufacturer supplied eye termination. They must be at least 85% of the minimum breaking strength. Accessory cord. It's a smaller diameter rope used for a variety of tasks for which the regular rope would be too bulky. It's soft, more flexible, it's easier to knot. It grips well when used in friction knots. It's usually found in sizes up to 9 millimeter. It's most commonly used as Prusik and mechanical advantage systems, also tandem Prusik belays, and can also be used for self-rescue with 2 different length Prusiks. Webbing may be preferable to rope in certain situations because of its special characteristics. It's more comfortable for seat harnesses, it's less expensive, commonly used for anchoring, more abrasion resistant to some rigging applications. It does not absorb shock loading as well, and there's fewer secure knots. What is the most trusted knot with webbing? The water knot. Webbing materials. Webbing is made from nylon or polyester. It has the same characteristics as the material used to manufacture rope. Some is made from spectra, has a high tensile strength but does not absorb shock loading as well as nylon or polyester. Webbing construction. You have flat webbing and tubular webbing. Flat webbing is constructed of a single layer of material, the same as seatbelt webbing. It's less expensive but stiffer and more difficult to work with than tubular webbing. Tubular webbing is more supple and easier to work with than flat webbing. It's more often used in the high angle environment. Webbing sizes range in width from a 1/2 inch up to 6 inches. Widths from 1 to 2 inches are most often used in high angle work. Larger widths are more comfortable for seat harnesses as they spread out the weight. Webbing strength. 1-inch tubular nylon webbing has a tensile strength of 4,000 pounds. And then all the way up to 12 and 3/32 inch flat nylon webbing has a tensile strength of 9,500 pounds. Determining the system safety ratio. The most realistic way to determine the needed tensile strength of the rope, and therefore its diameter, is to calculate the load ratio in the context of the system safety ratio. Determining the system safety ratio. The system safety ratio estimates conditions expected to be encountered in the local high-angle environment. It allows a margin of safety to be calculated based on the equipment used and the manner in which it is rigged. To determine the safety ratio for a particular system, you first analyze the elements of the system, then add a margin to cover what you don't know or couldn't anticipate. System load ratio. The effect of the load on the system as a whole is more important. The system load ratio reflects the relationship between the strength of the weakest point in the system and the highest force expected to be applied. System load ratio. Here's an example of a system load ratio calculation. If the strength of the weakest point in the system is 1,000 pounds of force, and the maximum load that is expected to be placed on the system is 500 pounds of force, then the system load ratio would be 1,000 to 500. Simplified, 2 to 1. Typically, rescue systems are exposed to much higher loads, and rescuers try to rig systems with a much higher system load ratio for greater safety. Challenges and considerations for calculating system load ratios. When calculating the system load ratio, you will need to factor the expected load on the rope that you are using, the strength of other components used in the system, for example, anchor bolts, anything else that may affect the strength of the various components, like knots, the number of people on the system, the conditions of the terrain or the environment, such as rope running over a sharp edge, and shock loading. System safety ratio. This can be determined once you have determined the reasonable system load ratio. Apply a multiplier of the load to make up for inaccuracies and unknowns in your system analysis. System safety ratio. To add a safety ration to the system load ratio, multiply the anticipated static load by at least 4 or 5. For example, First, we're going to establish a system load ratio and work from that. So if we have a 300-pound load and 9,000-pound capability of our system, that comes out to a 30-to-1 system load ratio. Now we take that safety ration of 4 or 5, we're going to use 4 for example here, multiply that by our 300-pound load. So now we're talking a 1,200-pound load with our 9,000 pounds of capability. So that now changes our system load ratio to a system safety ratio since we've multiplied in that safety ration. And that changes our ratio from a 30 to 1 to a 7.5 to 1 system safety ratio. Some rescue groups agree a system safety ratio of 7 to 1 is acceptable. Experienced rope technicians know the minimum breaking strengths of the various components they're using, the way those minimum strengths can be affected by the rigging methods, the quality of the anchors, and the force multipliers both in and on the system. NFPA guidelines for life safety rope. The NFPA classifies life safety rope into 4 categories: escape rope, technical use rope, general use rope, and moderate elongation laid life-saving rope. Breaking strength of rope is measured as tensile strength at break. Among the different factors that affect the outcome of a tensile test include the speed of the pull. The faster we pull, the lower the breaking strength, and the diameter of the object to which the rope is attached when it's pulled. A smaller diameter or sharp angle will also decrease the breaking strength. Minimum breaking strength. Breaking strength is the force at which an item breaks. No 2 samples of any item are going to break at exactly the same force. The minimum breaking strength is the minimum or lowest strength at which equipment is reasonably likely to fail. 3 Sigma method, the statistical method that NFPA and Cordage Institute, life safety rope standards, and most quality rescue gear manufacturers use to determine the minimum breaking strength of a piece of equipment. This gives the user a high probability of the rope he or she buys actually having a minimum breaking strength equal to or higher than the advertised number. This is found to be 99.87% accurate. How the 3 Sigma method works. You subtract 3 times the standard deviation calculated from the mean or the average of the test result numbers. The result, or lower, would be the minimum breaking strength the manufacturer should advertise. The deviation is the difference between the breaking strength numbers. The role of the fall factor. Fall factor is the relationship between how far a person falls and the length of rope that is available to catch that fall. The highest fall factor is a factor 2. Lesser fall factors will have a value less than 2. The role of fall factors with short ropes. The fall factor formula for dynamic ropes does not necessarily translate to static or low stretch ropes. This is especially true with very short or very long lengths of static or low stretch rope. The choice of a safety rope with some extra stretch versus one made from a very low stretch material can make the difference between a major injury and a minor scare. A rescuer can have a fall from a greater distance and still have a lower fall factor. This is due to having more rope to absorb the shock load. In summary, rope is the universal link in high-angle activities and rope rescue. Besides protecting the climber, a good climbing rope helps reduce the force that is transmitted to anchors and protection, causing them to fail. Rope used for rappelling and ascending does not usually act as a safety for the person on the rope, but instead as a means of travel. Ropes designed for rescues share some characteristics with ropes designed for single rope technique: low stretch and high resistance to damage from abrasion. NFPA 1983 delineates different types of ropes. Life safety rope and moderate elongation laid life-saving rope are the major ones for technical rope operations. Currently, synthetic fiber ropes are considered standard for situations in which the safety of a person is on the line. Several different synthetic fibers are used to make ropes. The choice of a rope for a specific job depends not only on the fiber from which the rope is made, but also on the manner in which the rope is constructed. Laid construction means that small fiber bundles of material are twisted and then combined in larger bundles, which are twisted around one another in the opposite direction. Plaited rope usually consists of bundles of fibers plaited together. The two types of braid used in the construction of braided rope are the solid or single braid and the hollow braid. A double braid rope is essentially a rope constructed of a solid braid covered with a hollow braid. The term Kernmantle comes from a compound German word, Kern meaning core and mantle meaning sheath or cover. A rope is the one essential element in the high angle system. If you are going to be doing only recreational rock climbing or mountaineering, your choice should be dynamic rope. Moderate elongation laid life-saving rope is a specialty line for supporting people during rescue at firefighting operations or training evolutions. The tensile strength of a rope depends very much on its cross-section of material or the amount of yarn used per foot of length. Although many people choose a rope color for aesthetic reasons, color also can serve a very functional purpose. Adding color to the rope material somewhat affects the rope's strength, and in some cases it affects the rope's resistance to damage by sunlight. A manufactured eye termination is a permanent loop in the end of a rope created by the rope manufacturer. Most accessory cord is soft and more flexible, resembling a miniature climbing rope. Webbing may be preferable to rope in certain situations. Most webbing is made of nylon or polyester. Webbing construction can be flat or tubular. Webbing ranges in width from 1/2 inch up to 6 inches. The most realistic way to determine the needed tensile strength of the rope and therefore its diameter is to calculate the load ratio in the context of the system safety ratio. The breaking strength of a rope is measured as tensile strength at break. The fall factor is calculated by dividing the distance the climber on the rope falls by the length of the rope between the person and the point of protection. The fall factor formula for dynamic ropes does not necessarily translate to static or low stretch ropes.